Our calculus unit.
Mr. Franz doesn't know how to count. Thank you.
Oh, there are two types of calculus, integral calculus and differential calculus. Generally, integral calculus was sort of worked on first, and differential calculus was worked on later, but we study differential calculus first. So we got some famous mathematicians that we can look at. Now, integral calculus is finding areas under curves, and you can go all the way back to the Greeks, and Archimedes, one of the greatest mathematicians of all time, to see that he was already doing the idea of integral calculus. Okay, differential calculus, that's related with rates of change. And it's now said it was discovered in the 17th century by Sir Isaac Newton and Leibniz. Now, they found it at somewhat different times, but it wasn't in the age of the internet, where if you posted it first, you knew that you had found it and the other person hadn't found it. I can scroll up a little bit. You don't need to look at their pictures too much. But what's interesting is if you would have looked at textbooks over the past 100 years, you would see that all English textbooks would associate the discovery of calculus to Isaac Newton, because he was English. And German textbooks would say that Leibniz discovered calculus because he was German. It's generally accepted right now that they both independently found the same kind of thing at relatively the same kind of time. Now, when we look at an average rate of change, that would be something like I'm traveling from here to Portage, right? Portage is 70 kilometers away, and it took me an hour to get there. How fast was I traveling on average? 70 kilometers an hour, because it took me an hour to get there in 70 kilometers. Now, that's not true of what I was doing all the way through, because sometimes I look at my speedometer and it said 100, and sometimes it probably said 110, or maybe, well, it's 110 now, so that's okay. Probably said 115 at some times. And whenever I look at my speedometer at that instant, we're going to call that an instantaneous rate of change. That's how fast I was going at the instant. But on over a period of time, that would be considered an average rate of change. So here we have the following graph. We can calculate average rates of change over the following interval. From 1 to 3. So we've sort of got, let's say this is time on this axis, and let's say time in what? Hours? Time in hours, and distance in kilometers. So we'll see if this actually makes sense. So what's our average rate of change from 1 to 3? Well, we have traveled 6 kilometers in 2 hours. So our average rate of change would be 3. And if we added our units, it would be 3 kilometers per hour. That's not going very fast. We could change our units to seconds. 3 kilometers per second would be very fast. From 1 to 4, however, our average rate of change is 0, because we're technically back to where we started from. So maybe you're going for a walk, a nice leisurely walk away from your house. Your house is at point 6 here. And then all of a sudden you're like, oh, I forgot my wallet. You turn back and get back to your house. And so on average, you haven't gone anywhere. And so your average speed would be 0 kilometers per hour because you're right back to where you've started from. And then from 1 to 5, well, now we've gone down 6. We're 6 kilometers in the opposite direction maybe from our house. And it's taken 4 hours, so our average speed would be negative 1.5 kilometers per hour. Now, average rates of change and instantaneous rates of change is based on slope. Slope is rise over run. In our question, it was kilometers over time or kilometers per hour. And so if we want to find the average rate of change between any 2 points on a curve, we just need to draw the straight line through those points and then find the slope. What we're leaning towards in calculus, I know I'm getting excited and jumping ahead, but what we're leaning towards in calculus is if we move these 2 points closer and closer together until they're almost on top of each other, we're going to draw a tangent line. And the slope of that tangent line would be your instantaneous rate of change. Or exactly if this graph was driving somewhere, it would be exactly what your speedometer would say at that moment. Yeah?